So Google create file, and this one we're going to call it US 98. I'm going to give it a modifier. So it's MODLRD. I'm going to say US 98 CSC for crossfit correction. Really call it whatever you want, but that's why we know. There's some other US 98 files, I think. Create that file. So this particular roadway, I haven't evaluated it to see if it needs crossfit correction, but that's just the point, is to show you how the template would work, setting it up, and how we can do the report. So while that's opening, I'll elaborate on the background of this. So crossfit correction, usually you end up with some variable depths that you don't know what they are. So some people like to see either the depths and or the slopes. Now, if that depends if it's a variable slope or a variable depth. So it depends what varies. So if you're doing variable milling, where you just say, okay, go down to the control point and then go 2% over, or whatever your slope is supposed to be, that would be variable milling, and you already fixed it. And then so you just put a fixed layer of asphalt on top of that. Now that's generally, from what I understand, the preferred method for contractors to use. But I have seen some people where they'll come in and do variable overbuild as well, or instead. So variable overbuild, you don't necessarily know the depth of the overbuild at each point. So we've had requests to create reports for that. Well, creating the reports doesn't. So we created the reports, and then we got some more bugs in Bentley software. They're basically there. It only works if you use in conditions, but if you use the stripping components and the overbuild components, it does not work correctly. So I'll show you those components when we take a look at the ITL. But so we have to set up the template a certain way, and it's not quite the normal way that you would set it up, that we've set it up before for resurfacing. So you have to have an in-condition defined surface. Once you do that, then the report should give you correct values. All right, so we're going to attach the references that we need. I have created a blank file. I'm going to attach, I need my alignment, and I need my design, and I'll bring in the existing features. Those are 3 miles I need from there. I need the default model for the alignment. Everything else is the default model as well. And then I need my ServRD. I'm going to use the attach survey reference tool. Attach the ServRD01. And this may take a minute to attach all of these. So while waiting for this to load, have you determined how you're going to do the variable, or how you're going to do the cross slope on your project? Is it going to be variable milling or variable overbuild or both? I don't know whose project it is.
I think we were aiming for more of a general example when asking for the cross slope correction.
You have okay. You haven't made the determination.
No.
Yeah. It says not bugs, but feature defects. No, if it's Bentley's problem, I call that a bug. In fact, pretty sure we filed a defect report, so I guess they call it defect.
Get Mike to get after you then. Matt, you're supposed to get on that too.
So there's something that we can look at while we're waiting for that to load. I'll go ahead and show you on the C drive. The report is going to be located, it's going to be in the program files, and this is where it comes into problem. You actually do need admin access to be able to edit this, so this is something that we're trying to see if we can update as to where this file is going to be located. So it's going to be on the Overbuild Designer Connect Edition, and then I think it's in the defaults folder and the reports folder. So these are all the reports that show up, like when we did the super elevation, all of those were in there. That whole folder shows up. So under, I believe it's in a corridor modeling, we have the proposed slopes report and a depths report. So these files, easiest thing is to edit them in something like Notepad++, because it gives you nice coloring. But you can edit it with the straight up Notepad, any text editor. By default, it might open in something like Internet Explorer. You don't want to do that. You want to make sure it opens in like Notepad, some kind of thing. So over here, there's a section that you got to edit if you want to use these reports. And basically, for this slope, it'll give you the slope between any 2 points. So over here, you have to put the point names for the left and right. Here you can name the column. So this is just how it's going to look in the report. We basically have a column header, and then you just put, okay, so this, this is my edge of pavement or something like that, and here's the 2 points. Or actually, it would be more of a lane. So I guess this might be your shoulder. This might be your left lane, etc. So you got to make sure these points, these names have to exactly match how it's worded in the template library. So my recommendation would be to copy and paste them in. That'd be the easiest way. So the first thing I'm going to do is I'm going to make a copy of this report, and I'm going to paste it here. And see, it's asking for an administrative permission. This is where, if you need to do this, I think based on our setup, you're going to have to contact Danny to help, and or contact us and see if we fix the problem by the time you're ready to do this. So I'm going to say this is proposed slopes for, well, let's say for US 98. And it has to be in this folder, at least right now. That's what we're trying to maybe adjust, so that it can be in a different folder, but it would still probably be in a global folder. Unfortunately, this particular file even though it's going to be project specific, the way ORD reads it, I don't think we have any way to reference the current workspace project folder, but we'll look into that and see if there's an option to do that. So right now it's going to be saved in this folder, so this will show up in the list of reports. So that we can edit to say whatever we want. So on this particular one, I do know for columns, and we'll get the names when that's open, but I do know for columns, that might be open. No, it's still working. Let's say we have left shoulder, and then you have it has left widening, and then it has left lane, and then this right one, right lane, right widening, and this one's a little bit of an oversimplification of what actual requirements are for this particular corridor, but you get the idea across. So you can add or delete to any of these columns. The trick is it has to be this format. And we've got a little bit of instructions here at the top if you need it for reference in green here. So you can modify it. So I only need these 4. And I should have done a save as because I'll just overwrite that. Yeah, I think that was my shared privileges. And you should be fine editing this file even while ORD is open. Just don't have the report browser open, but it should pick it up without any difficulty. Okay, so we have the right widening, right shoulder. So these I can delete all the way down to here. So when you delete, or when you highlight anything, you just need to go from the opening left bracket, angle bracket, where it says angle bracket column, to the closing angle bracket / column. So I can delete, if I just want to delete just one, I can go like this. As long as I got that whole section, it'll be fine. I don't need to worry too much about white space. It's not going to make a difference, an extra return, but just, don't do something like that because that'll break the file. It won't work right. And if I want to add one, I can, as long as I'm following this format, so I can just copy this as a reference and I can add it in. If I want to reorder my columns, I can do that. If I want to move something around somewhere else, I can do it the same way, copy and paste. Just make sure, and you can shift them over with tabs if it's easier to follow. Just make sure you have this full thing, column to column, and left to right. It has to be this format. There's a sample up here as well. So it says, why this is going to be what shows in the table header. This has to be the point name from the template. So all of these are going to get deleted. This will clean up our, and it says do not edit below this line. So this is all you need to edit. I'm going to save that for now. We'll come in and edit the point names once I get the template library open. Still spinning. See if I can remember what they are. So this particular one, we have friction course as well. So let's see. It's going to be LT something. Technically, you can measure it at the friction course or at the structural course. It wouldn't matter in this case because it's consistent depth. So you can measure whichever ones you want. My slope is going to be fixed. So probably I probably don't need the proposed slopes so much as I need the depths. So let me edit this one. The FDOT depth is similar. So the section edit, the only difference is it's got a component section because this is measuring at points. So if I have my left lane, I usually have two components, right? So my left shoulder, I have the outside point, the point on each side of that. So I can basically group the columns, and it's top to bottom. So I can have multiple columns within each component. So it just like adds another header, basically. It's a different format. So on this one, I would have, well, let me do save as on this. I'm going to say depth. US 98. So on this one, I have left shoulder component, and I'm going to have a left widening. That's the other nice thing about using Notepad++ is it'll highlight to make sure you have both closing and opening brackets. And then after my widening, I have left lane. And then I have my right lane. And then I have my right widening. And then I have my right shoulder. And that actually happens to match the numbers. So I don't need to add or delete, but you can do the same way. You can add or delete these. As long as you have, so you can add components. So that's going to be a whole other section, whole other lane usually. Finally open? Nope, still working. Is anybody else's that slow? I don't know why my computer's running that slow.
Mine was able to load, but the first time I did it, it took a long time.
Okay. All right, so I've got the shoulder points. Now each of these, you can have as many columns as you want. So I know I'm only going to have 2 columns at most. Let me see. Yeah, so I'm going to delete that extra column. So the same concept here. You got to go from as long as you get the opening and closing brackets, you can delete. Let me see. Oops, I need to delete 2 of these. The widening, there's 2 points. It's really only 1 point because this point and this point, or the left point would overlap. So I'll just reduce this to 1. It shouldn't matter. Okay. So the widening only has the same thing. It's only going to have 1 point. And I'll leave 2 points in here for my left line, but I think I've only got 1. And that's going to probably be the center line point. Line. Should only have 1. And the right shoulder should only have 1. So, I can name each of these, this between quotes, that's whatever you want. So that's going to be, I'm going to call it as your shoulder. And then this is our edge of pavement. And then this is going to be the I don't know what to call it. So then we have the center line. Typically, this would be your pavement crown. Just the way that one's set up, the center line and crown are together, but you have to set them up differently. And then I got my right lane. I've got my lane. Yeah, the center line. So this one's redundant. I'm just going to copy and paste these. And in the same way, I have to get the points that I want to measure the depths to from the template. So this is finally opened.
Mic off.
So it should be ready to go. Same thing that we did in the other model
Mic off.
file. You have to make sure that you have a
Mic off.
profile, an active
Mic
profile,
off.
and make sure that you have the active terrain model
Mic
before you
off.
can build any corridors. My computer
Mic
sounds like
off.
it's an airplane about to take off, so
Mic off.
it's working hard trying to do something.
Mic off.
All right, so I'm just going to hit tab on
Mic
this
off.
to get to the right. Make sure I get the terrain model.
Hey, John Mark.
Uh-huh.
Mic off.
Question for you. Danny was in there, and I kind of have it too. So this
Mic
customization
off.
that you're doing is project
Mic
specific
off.
for your template,
Yes, it
your
is.
IPL that you're doing. Okay,
Mic off.
that's what I told Danny.
Mic
But I just want
off.
to make sure.
Yeah.
Mic off.
And that was something you might,
Mic off.
whoever needs to run the report, you might want to share it with them too. So it has to be on everybody's machine that needs it. But only that needs to run the report. Doesn't have to be anybody that uses the project. Okay,
Mic
so I'm going to
off.
set this as active terrain and make sure
Mic
this
off.
center line has an active
Mic
profile.
off. Mic off.
Active profile exists. Okay, I can run a corridor. So let's take a look at the template library. So you can see I was setting this up from memory, but you see the template that we have. And I'll show you how it's set up a little bit. It's a little bit different than usual.
Mic off.
All right, well, that's taking its time to make sure I got this ready. All right. I think it opened up. Okay, so it went straight into this one. This is the one I've set up across the correction. So what we have on this is in conditions. So you just would, if you want to draw this yourself, you can do add a new component in condition, and start here, go down to here. So I've already set it up, so it's good to go. So what this one is doing, the condition is just looking for the surface. Now, there's probably more that needs to be in here, so it's looking for the active terrain. So what we set on this one was the control point in the center. Now, more often than not, the control point's on one side, But on this particular project, because we're doing widening and shoulder on the sides, I think doing it in the center works okay because this shoulder is going to get redone anyway. So what this one does is the milling point ties to, at a milling depth, it ties to this point on the surface. So this finds the surface. This is the end condition. And here finds the surface, and this is our milling depth. That goes down below that and mills. So we do have the milling components in here. That's just really to show what the milling depth is. But the milling depth is fixed here. Don't recall for sure if this is going to work correctly to show the depth on the milling on this side, since you don't know this depth. We can test it and show on that. And this is just set on the bottom, or in the top, it's following the surface, the stripping component. And that means wherever the surface is, it's gonna vary. The bottom is following the component, which means it's following between these 2 points. Whatever these constraints are, that's the bottom. So I've constrained this to be surface here and go 2% over from there. So this point I need to show the constraints on. So this one is not constrained to the surface, it's just 2% from this point. And the right side is mirrored of that. So both of these just come 2% over. So the points we'd want to measure, so yeah, I don't think we need the slopes because we know that's 2%. This depth we know, so really the only depths that we need would be this depth here between the surface and the milling point. So let's measure that. So I'm gonna copy this, just do Control C, and then I'm gonna paste it in the depths report. So this one is the left lane, and this is the bottom point. If you flip the top and bottom, you just would get a backwards, you'd get a negative number. The surface, actually no, this more than likely is the top surface. We don't know that for sure, technically could vary, but if it's not, if we don't mill to that depth, then we're in trouble. So I'm going to assume that's the bottom surface. And then the LT milling in is that's our bottom. So we're going to assume it's the top surface. So we have some milling depth. So typically you would check and make sure that works. So this would get you started. So, and the right one I think is mirrored of that. So let's get that point. That's the right milling in. So I'm going to paste that over here. That should be the top. Oh, that's sorry, that should be the bottom. Then we have the right pavement break surface. That should be the top. All right, so just for good measure, I'm going to put in the depth here because we know, even though we know this, I'm going to put it in anyway because you can do depth between any 2 points. So the surface is on the top, the center line. And then the bottom would be this milling out point. And I don't want to see the need to repeat it, so I'm just going to delete it from the right lane. Okay, so Great. So we can take the points anywhere else that we want to see, but this depth is fixed as well. So I'm just going to skip those so I don't have to go through and set up a whole bunch. So I'm going to delete these components. So that means we're going to be left. In the same way on this one, if you need to reorder any of these, you can do that as well. So you just follow the format it's referenced. All right, so I just have the left line and the right line, so those 3 points is all I'm looking at. It's going to be a simple report. All right, so do you understand more or less how this is set up? So the milling is a stripping component. Then the overbuild comes up at a fixed, it's just a fixed structural course. So whatever your fixed pavement design states, plus then you got your friction course. So the only thing that varies really, you got this in condition, and you got the milling surface. So
I have a question about. Sorry, I have a question about the milling line, the component itself. I know that there's a template for the milling, but there's also a shape. How does that intelligence work? Because I've had situations where my milling line doesn't point to the surface correctly or overlap the desired location. Like how, I guess what would be the correct workflow, and I guess some of the reason behind the intelligence of the milling line component?
So this one, this milling line, that's what I use in the template, is a stripping component. So it's got different settings that will allow it to follow the surface. So if you need variable milling, or if you just need to go to fixed depth, you can use the stripping component. There's no problem. If it's a shape, it's probably you've got to use in conditions or something like that. So if I were doing, for this particular one, come back to it, if I were doing a fixed milling depth, I could use a regular shape because I have the in condition finding the surface here and I have it finding it here. I would just tie it here and tie it here. The only caveat with using a regular shape there is in between any variations in the slope, it's not going to follow it. So it wouldn't be as accurate as if you use the stripping component.
Okay, understood.
Does that make sense?
Yes.
Okay. In this particular project, there's a short widening section. This one will find this pavement. I think we just need to add in references, and it'll show that up. So let me create this corridor. Select my baseline, reset fractal profile. I'm going to blame GoToMeeting as to why this is lagging, because this computer is my desktop that I'm using. Should not be lagging this much. Yeah, it's that the anti-malware that's running slowing me down. Can't do anything about that. All right. It's letting me select the template. All right, so my template here is going to be this R98 cross-slope correction. And then I'm going to start it down here. And I'm going to end it, looks like the line work ends about there. And 20-foot drop interval, I think is correct. So now it's got something in there. Let's take a look. I'll do the F4 so we can bring up the profile and the cross-section view. I select the corridor for the cross-section view. So I have options to do dimensions. All right, so you can see the stripping component here is following this existing ground. So if I tab through it, I can see both the milling and the existing ground. So, this is what you have to look at. Well, is that enough milling depth? You might have to change your control point in a real world project, but for this particular example, I'm going to leave the control point right here. So it is adjusting the cross slope. So this is a fixed 2%. If I do horizontal dimensions here, all right, so 2%, roughly 12-foot lanes on each one of these. All right, so, and if we do constraints and things like that, it would potentially change the width, but in fact, I probably should do that. The center line should be here. But first of all, I want to run the report and show you how to do that. So go over here. We got these reports here, but what I want is a results report, which is from the corridors. So I usually just go in and select the corridor in a 2D view, get the little paperclip icon, and click on the results report. So now I have these proposed slopes that I created. I didn't change the names for that, did I? Depth for US 98. There we go. So I changed the names for these, so it's showing up. I don't need nearly that many decimal places. Let me see. It should be, oh, this should be linear. They may have changed some things in this version. It's not working correctly because it won't change the places. So if you want to verify that this is working, so these are your variable slopes. So the milling out is 0.33. So you can see that's working correctly. That's 0.33, and that's what we set it to. And then these are all our LT-FCN. The proposed slopes for the left lane is LT-FCN on the left side, and then the right side is FC out. I'll do the right lane the same way. Oops, that's the right point. And I'll just delete these to simplify it. Save that. Now go back to my results report and see if you can see the slopes. Now it's going to be fixed. Unfortunately, the way this template's set up, you're not going to have a lot of options. So this would be typically if you're doing a variable overbuild. So if I run here, it's proposed slopes for US 98. So there's my report. Now that I changed the names, it gives me values. So yeah, like I said, it's all 2%. But if this were varying and you don't know what this is, as long as you got these points, and as long as they're using in conditions and not using stripping components or overlay components. Now I use a stripping component for the milling, but that's only because it doesn't need to follow the top of the milling. It's just looking at the existing ground for that in condition to follow the top. Now, there's a way to set up the component to follow the surface and go a fixed depth below it without using the in conditions. If you set it up that way, it will not work. Same goes if you do a variable overbuild. You can also do a stripping component. This is overlay stripping component. Same concepts, but if you're trying to measure any of the depths or slopes, they will not work on there. So if you need to do a variable overbuild, say your milling is a fixed depth and you're doing a variable overbuild, conceptually you're going to have to do it the same way where you use in conditions to go to the right place. So you're going to probably need to do is not use, if you're doing a variable overbuild, not use the milling as the base. Use a in condition and go so far below it if you need to be able to measure the slope on there. And use so if I wanted to vary the overbuild, for example, my milling was fixed, I would assign this, I would assign it to be a fixed depth below that. So -0.33. That's my milling depth. Now, when I set it up that way, I don't know what the slope is for this. But the thing is, this overbuild is constrained to the milling. And let me see here. I can test it and we'll see how it behaves, and it'll tell us whether it'll work right or not. So you can see it's matching that existing slope over there. I think you'd have to, I think you'd actually have to break this point out for it to work correctly. If you're doing variable overbuild, there's nothing to say we can't test it. So let me just save that, synchronize it. Oh, well. At this point, it's not correcting the cross slope. Typically, you would what you do is you would set this top point to be a slope off of that, so that would be the varying if you're doing variable overbuild. But I'm going to leave it because I want to measure the slope just to show you how the report would work. So let me synchronize that. Synchronize already? Point 3.3. Yes, it did synchronize. That was faster. All right, so now I can run the results report on that. And if I look at the proposed slopes, then I have a varying slope. So you can see to the right, I left the same. This one I varied. So if you want to check it, what's our station 21 is 2.423. So I think the way this one's constrained, it works okay. If you've got questions on that, I'm going to have to suggest that you contact us because this one, it is a little bit finicky on the stripping components. And this one, like I said, I did the milling as a stripping component. I think the overlay, because the overlay is not a stripping component, it works okay. If it was, then you probably would be in trouble. 2.47 at station 22. Yeah, it seems to be giving the correct values. Any questions on this? Everybody understands it's fine?
No questions.
All right, like I said on this one, you forget how to use this, that's fine. That's why I have kind of the instructions here. That should help you, remind you if you need to go in and edit these. What I would suggest doing for the time being is make a copy from here. If you don't have admin rights, make a copy and just save it somewhere else locally to do your edits. Your desktop, your project folder probably makes more sense. Save it there, do your edits, and then get your administrator, which would probably be Danny, to put it in the program files folder for you. So it'll be this location. If you ever forget what this location is, that's not a huge deal either because it shows up in the reports browser. If you open that report again, so this path right here is where all the reports are located. So you can find it right there. So I wish there was a way to do something a little more intelligent that you didn't have to edit that file, but it's hard to know what you want unless you spell it out, basically.
I think it's better. It's a better control, controlling the report.
Yeah.
I think it's better this way.
I know in a future release, there is a variable to where we can have a second location of those custom reports, John Mark. That is coming out evidently to give on one of the updates. So we just got to test the best place for it of where we need to deliver those reports. Because if we point it to the server, they're gonna run into the same thing. They're not gonna be able to get to the server to edit them.
Right. It's got to be a local place. Yep.
Maybe we need to look to the project or the work set specific one. That's something we need to test before we get it out.
Ideally, it would be work set specific. I just don't know if there's any variables that I can access to have it look for a file in your work set folder.
That's coming in the next release, 10.9.
Okay.
to look
Okay.
for it. We haven't implemented it yet because it's not available until 10.9.
Okay. So yeah, well, we'll probably have changes on that coming up, but that's the process as of today. 10.9 probably won't be out till next year, I'm guessing. So, any other things that we need to address as far as core modeling
Mic
goes?
on.
Any other questions on it?
Would going into detail of end conditions be done at a later time, or
What do you want to know about end conditions?
just I guess the different methods in terms of like developing a swale or doing end conditions at a corner, or certain restraints, or how end conditions could be used to make the to do a more efficient model?
We can make a note to cover that on next Wednesday, I think.
Okay.
We had a interesting problem with one of our projects with the end condition. At some spots, and we couldn't figure out why, instead of tying to the surface, it tied all the way to the other side of the model to the surface over there. I'm not sure why it was doing that.
Usually that is because of point name overrides. That's what I've seen.
I got you.
And or your ranges and your constraints, if it's looking the wrong direction, or it's looking it's looking in a direction that it could happen to fall in a range, and some of that stuff gets counterintuitive because so there's a location every point here. So if you got a feature constraint on it, but it starts out by looking at where is it located here. So if I have a horizontal feature constraint on this point, which one of these points does, I think it's this point, structural course. So this has a range of 99, so that that should find it with no difficulty. However, it's going 99 from this 20 feet over. So say I had the range of 10, if this one also has a horizontal feature constraint, which it does, pretty sure, it's looking for that milling line, this one is going to find it, so this is really only 20 feet over, something like that. Sorry, no, 12 feet. I think it's like a 12-foot lane. That's 20 feet over from the insertion point, which is over there. And so it's going to go from this location 20 feet to the center line, 99 feet over, even if this moved first. So you can't say, well, my milling line, let me turn off the, yeah, that might be a good idea. That's the best way to see it. So I've made sure most of these, like in the templates that I set up, I made sure most of them work.
We actually had another issue.
I'll show you the process.
We were doing a display, like an if statement for the display,
Mm-hmm.
and we told the back slope to be 1 to 4, but for some reason it's not doing it 1 to 4, and I'm not sure why. So I guess that's all tied into the same project with the end condition.
Okay. Yeah,
I
we'll
could
have to
also
get into
email it out
conditions.
if you want. I could send it to you.
Yeah, sure. Why don't you send it to me and I can take a look at it.